Let's get started. Hi, my name is Tomo, which is impossible to pronounce, so don't worry about it. And I'm here to talk about Scala. So just to set the stage, this is sort of an introductory talk. It does not assume that you know pretty much anything about Scala. If any of you are already using Scala or intimately familiar with it, this may turn out to be a little boring, but you're welcome to stick around. And I mean, if there are any questions or anything throughout the presentation, just raise your hands. We'll stop and ask them. This is ideally supposed to be a dialogue, but if not, that works too. So let's get started. What are we going to be talking about? So the idea behind this presentation is to sort of give you basically 5 elements that should help you either make the choice or drive the choice in migrating to Scala within your organizations. And that focuses around these 5 bullets. So the progression is I'm going to try and convince you, and if you're already convinced, I'm hopefully going to give you a few tools to convince others that Scala is an interesting language to look at. Then I'm going to give you some ideas on how to convince the team around you, and then how to convince your boss. So that's the idea. Why should you care? I'm not going to be talking much about me. Suffice to say that I've been dealing with Scala for quite a few years now. I'm a co-founder of both the Israeli Java and Scala user groups. So I've had a lot of exposure to various companies in various styles, startups, enterprises, traditional enterprises, all of the spectrum of companies, and trying to convince them that Scala is interesting and worth looking into. And the company that I work for is called Wix. Is a moderately sized company. We have quite a few technical challenges. We've been a Scala shop for about 3 years now, since 2012, and we do all of the stuff that you would, expect a company that's not very old, but also not at a startup phase to do. So we have microservices. We have a large Java legacy code base that we still have to interoperate with. So this should give you some idea about, the sort of challenges that we have and how Scala helps us deal with them. So let's get started. The talk is 5 bullets to Scala adoption. The first bullet is the pitch. Okay, I'm gonna try and sell you on Scala, and if you're already sold, maybe you can use the same set of arguments to sell Scala to your teammates. So to start with, let's take a look at a very kind of rudimentary and commonplace Java code. Okay, what we have here is a class. That class is called person. 3 fields: name, surname, which is basically family name, age. We have a public constructor. We have a bunch of getters, and we have a toString. Okay, nothing fancy, nothing complicated. You've all written code like this probably 100 times in the last month alone. Next up, we have this person class. Presumably we want to do some stuff on top of it. So for purposes of our test code, we may need to randomize some people, right? We may need to generate people, person objects for our test code. So the first thing we're going to do is we're going to set up a bunch of static lists, just a bunch of names and a bunch of family names. If it's not obvious, these are Big Lebowski characters, and if it is obvious, then good, because it's a good movie. And then we have some generators, right? We instantiate an instance of random. We have a function that generates a person, just takes in an age, randomizes a name and a family name, returns an instance thereof. We have a function that does much the same, except for a group of people. So if we need like a collection of 20 people to run some transformation over, we'd probably use this. We give it a count, we give it an age, it produces an array list, adds random people to it, and then just to sort of be nice and complete about it, it wraps it with an unmodifiable collection. So this is all pretty standard fare, right? Does this take anyone by surprise? Does anyone have not seen code like this in the last, say, 24 hours? Cool. Okay, so this is pretty simple stuff. Now, let's do some Scala 101. Okay, let's see what the same sort of code would look like in Scala. So the first thing we have on left is a condensed and probably unreadable form of the same Java class that we started off with. That's our domain object. That's our person. In Scala, it would look like this. Okay, we have something called the case class, and I'll explain what a case class as opposed to a normal class is in a second. We have a case class. It's got 3 fields, name, surname, and int. Now, a case class in Scala is a special case of class. It's basically syntactic sugar. It tells the compiler to generate a whole bunch of stuff for you. So in practice, what we get is if we mark the class as a case class, we get for free a public constructor, a bunch of getters, hash code to string, equals, all of the sort of basic stuff that you would expect from a very simple kind of data object. So what you can derive from this is that a case class is really just shorthand for generating basically data transfer objects, DTOs. Right? If you want a domain object and it's simple, just use a case class. So it's gonna save you a whole bunch of unnecessary code. So that's cute and fun and saves a bunch of code. It's not very interesting, so let's move on. Now what we're gonna do is we're gonna take the Java code that we just looked at and just transliterate it into Scala. We're not gonna use any of Scala's more, shall we say, interesting features. We're just gonna show what the same code would look like in Scala, just doing the exact same thing, same idioms, same everything. So we have, to begin with, we have our generator class with its static initializer with a bunch of names. In Scala, it would look like this. The first thing to notice is that it says object here instead of class. And that's because in Scala, singletons are first class. Okay, you have this language construct for a singleton. It's called object, so you don't need to fiddle with static initializers and the double locking pattern and all that stuff. Once again, it's cute, but not particularly interesting. The second thing to notice is that there's no static initializer. Okay, the body of the class is always essentially the flow of the constructor for that class. So with an object that's a singleton, anything that happens within that body can only ever happen once. So you don't really need a static initializer. So we just declare the fields, you know, private val. Val is a value declaration. Okay, val is analogous in Java to a final whatever it is. Okay, so this means that the names field can never be changed after being declared. And we just feed it a list of people. So the differences are pretty small. You'll notice that for generics, we have square brackets instead of angle brackets. You can sort of filter these things out of your mind. Okay, syntactic differences are not the big deal here. Okay, if you take Java and just change a bunch of stuff, you change, you know, the characters that you use, it's still Java. Okay, so this is conceptually the same. We just translate the code to Scala, and this is what it looks like. Moving on, we have our generator classes. Okay, generate person and generate people. So we would have the same random, right? Private value random of type random equals random. The second thing to notice is that the type annotation in Scala actually follows the name annotation. So whereas in Java you would say, you know, public static random being the type, random being the variable, here you'd have this colon separator. It's Pascal style type annotations. Once again, it's just syntactic difference, not a big deal. To declare a method, you use def, okay, and it's public by default. So def generate person takes in one parameter of type int, it's called age, and it returns a person. And then you have pretty much the same thing, right? We pick a name at random, and then we return a new instance of person. The generate people looks a tiny bit different because it uses Scala collections instead of the built-in Java ones. So whereas in Java you would use new array list, in Scala you would use a mutable something called list buffer, which is essentially an array list, except in Scala collection framework terms. And then you would have a for loop that looks pretty similar. It counts from 0 to whatever count you gave it to, non-inclusive, and then it just adds people to the list buffer and returns the result. Okay, so this is pretty straightforward stuff. You'll notice two interesting things. First, there is no return keyword, or rather, there is a return keyword in Scala. You just don't use it often, or if you have any sense at all. In Scala, everything is an expression. You don't have statements. Right? In Java, an if doesn't have a type. An if is a statement. You state to the compiler, if some expression, do this, else do that. In Scala, everything is an expression. So if has a type that derives from both the then and the else cases. Try catch is an expression. Okay, the whole code block for this function is an expression. And an expression always takes its value from the last sub-expression within the block. So if the function itself has a whole bunch of, like for instance, the generate people function has two local declarations, and then it says new person, whatever. This is the last expression. This is what gets implicitly returned from the code block. So this might seem like a trivial difference, but it's actually really, really powerful because you can compose stuff. Like in Java, for instance, how many of you use the what's called the ternary operator, basically the question mark colon? Okay, pretty much all of the hands are raised, right? And it's always a bit fiddly. It feels wrong, okay? Because you need to take special care. You need to sort of format your code for it to, to make sense, so that the people reading it absolutely know if they're looking at the if case, the then case or the else case, right? It looks a bit off, but then you still use it because it's convenient to be able to just stick an expression and get a value back from it. And the ternary operator is the if-else in Java. It's the only thing you can use. Okay, so in Scala, you don't get that duplication. Everything is an expression. Okay, there are no statements, and that's actually pretty powerful. The second thing to notice is that the for syntax looks a bit different. Okay, fors in Scala are actually what's called for comprehensions. So the loops that you're sort of used to in Java. In Java, really, you get two types of fors. You get loops, like counting loops, the old type of loops since before Java 5, and then you get the iteration loops, the for each, basically. Scala generalizes that, so you get both these types of loops, but then you can do a lot of interesting things with for. People who have done any sort of long-term development in Python are probably aware of this concept of for comprehensions. If we have time, we may get back to that, but it's a pretty powerful construct. Okay, so this is what we started off with, right? This is everything that we've described so far. It's just basically Java written in Scala. There is nothing new, nothing interesting here. You have the object, you have the stuff in the static initializer, and you have the two generators. Now we can start looking at things the Scala way. So let's start trying to figure out how to make the code either better or simpler with what Scala has to offer. So the first really, really simple thing is type inference. Okay, everything that is marked in red is incidental. Okay, essentially, it's us telling the compiler something that the compiler can figure out on its own. Okay, if you have a local variable that you assign to a constant, basically, to a list of stuff, the compiler can figure out that it's a list of string. Now, in Java, and actually most sort of, I don't want to sound like an asshole about it, but sort of previous generation languages, Java, C#, a lot of other languages, at least up to a certain version, you literally have to tell the compiler everything. The compiler doesn't make any inferences. It doesn't figure out things from the code that it can based on a context. In Scala, everything that is marked in red is redundant. You can have it. In some cases, it makes sense because it aids code readability, but it's your call. You can basically omit all of these declarations, all of these type annotations, and then your code becomes a lot smaller. Now, this might seem like a small thing, and in a sense it is, because it doesn't change the semantics of the code that you write, but it reduces a whole ton of code. Now imagine that for every stupid class like this or stupid function like this, you just saved yourself, dozens of characters that you had to type, potential mistakes, things that need to be corrected in refactoring, renaming, all that stuff, and you didn't add one bit of readability to your code just by having these type annotations. You don't need them, okay? This is not any more readable than this, maybe less. Okay, so it actually saves on a whole bunch of code, and it really, really aids you in writing simple readable code. So this is just square one, right? This is the first interesting thing that comes our way. Second is the collection framework. So whereas Java, up until very recently, just didn't get a whole lot of love, I mean, the collection framework has basically been the same since Java 1.4 up until the streams API in Java 8. Okay, not much has changed. Scala's collection framework is actually extremely versatile and powerful. It looks a lot more like the sort of massive collection framework that you get with, once again, Python is one example, but also C# used to be a lot better than Java in that regard. So, just to give a few examples, we'll start off by using our generator to generate a whole bunch of people, and then we can start doing interesting stuff with it. So at this point, I'm not gonna, I used to have these 3 slides about lambda expressions, but nowadays with Java 8, they're actually sort of commonplace and well understood. So I'm not gonna focus on them. Suffice to say that Scala has had lambdas for about 10 years now. If you wanna extract the names, you have a bunch of people, you just want the names, then you just map over them. Okay, you can do something a little bit similar with the Streams API, only it's slightly more verbose, but it's only sort of the tip of the iceberg. You can use map to transform objects. You can use filter to extract objects. So if I have a bunch of people, I only want the adults in the audience, I can just put this put this predicate here and just get back a list filtered by members of the audience who are adults. More importantly, functions are first-class citizens. So whereas you can get some of this functionality with Java, with the double colon operator in Java 8, this is actually a much simpler way. You can just take a function and pass it. Functions are values. You can pass them around freely. You don't have to think about it. You don't have to worry about method handles. You don't have to worry about method references. You just pass them and everything works as expected. So this is a really, really simple example. The same predicate implemented as a first-class function and then just passed to the same filter function. This is a pretty powerful thing. You also get a whole bunch of interesting sort of additions to the collection framework, a lot of stuff that you would have to, it's not hard, right? But for instance, if you wanted the minimal age in a Java collection, you'd have to write the iterator on your own, and you have to sort of do the if on your own. It's not a big deal, but you get it for free, so it's nice. These are just a bunch of examples. Obviously, you also need things beyond just lists, right? You need maps, you need sets. So maps are also first class in Scala. So this is an example of a pretty trivial string-to-string map. And you can do all sorts of stuff with it. You can group from it, right? You can take you can take a bunch of people. You can say something like, okay, I want a dictionary, right? Like a phone book of people. So what's a phone book? It's just an index of the people that you have. You take the first letter of their last name, and then you list the people that have the same first letter. So this gives you that exact functionality in just 3 lines of code. And that's something, just a small example of the sort of power that you get from for free from the collection framework. So it's a massive library. The Scala collection framework does a lot of different things, and mostly it does them very, very well. You end up with code that's pretty legible, pretty readable, and it takes you a lot less effort to write and a lot less error prone. Questions are there, if there are any? Okay. Some more stuff. We're gonna be done with sort of a feature walkthrough in about a couple of minutes and start talking about other interesting things. Options. Java 8 has optionals, which is largely the same thing. Once again, Scala's had those for years and years. So the idea is that nulls are a bitch to work with. Okay, nulls are hard. If you want to have a class where some of the fields are optional, okay, you have a person, you may or may not know that person's age. How do you encode that in Java? So if it's a reference type, the sort of convention is to use nulls, and then annotate in the Java docs that you have here a parameter that can or cannot be null, and it's documentation, right? It's text. Even if it's Java docs, it's basically text. It can go out of sync. Someone actually needs to read it. How many of you actually check the Java docs for a function that you use? Wow, there's more than 3 fingers, 3 hands in the air. I'm surprised. Okay, most people tend to just brute force through it. There's a function, it's got the right name. There's a parameter, it's got a name that makes sense to me. I'm going to stick something in there that makes sense. I'm going to try to run my unit test and perhaps blow up half of Manhattan. But never mind that. The idea here is that people don't read. They don't care about the stuff that you write in your documentation or your comments. Either the names are good and the code makes sense, or people will start head scratching. So parameters that are nullable are an issue. Because, for instance, if I were to encode the same sort of partially known person class in Java, I would take the age as an uppercase I integer, okay, as a boxed integer that may or may not be nullable. And then whenever someone calls my getter, calls getAge, they'd need to do the null check, because if they reference it into an int because they assume that age is always known because it's not obvious from the signature, then their code will inevitably blow up. So an option in Scala, much like optional in Java 8, is basically a collection that has either no elements or one element. Okay, it's just a container. And the important thing here is that you can't get at the contents of the container implicitly. You need to do something in order to get at the contents. So you can't just take this age that's an option of int and just use it as if it were normal int. You need to actually get at the contents of it somehow. And you can do that by using, person.age.get, and then you'd get an exception if there is no age, if it's unknown. Okay, but it's actually not the best idea, because then you're relying on the fact that you've done some if check beforehand. The thing that you should do is you should treat it as sort of a 0 or 1 element container and use the functions that you get with it. So if you want, if you don't know the person's name and you want to print it out, so you want a default value, just use get or else. If you want to transform, I have an age, now this person is 1 year older, and the age may or may not be known. I want to do it in a safe way, and I don't want to use ifs. I want the code to just be flat out obvious in what it does. Then you can treat it as a collection. You can for each on it, you can map on it, you can filter on it, you can do all of those interesting things. And most importantly, you don't need to comment anything, because the very fact that you've annotated something as an option gives your users and your future selves everything they need to know about that field, the fact that it's optional and how it's used. Okay, there's no place for ambiguity here. So this also seems like a really small feature, but it actually saves a ton of time and money. Okay, the last time I've seen a null reference pointer exception null pointer exception or null reference if you're coming from the C# world in production was roughly 4 years ago when I started off with Scala. The only reason why I would ever see these again is if I'm interoperating with Java code that still expects nulls. So I have to deal with nulls. Okay, Scala doesn't stop you from using nulls, it just discourages you from doing that. One small thing is that Scala has named parameters. It's sort of an on-the-fly feature showcase. You can, if you have default parameters, like name option string equals none, that's the default value for that parameter, then you can just name your arguments, and then you don't have to worry about things like positioning, and the code is pretty self-documenting. It's a very small but pretty sweet feature. Last thing we're going to discuss before we move on to how to, assuming that I've managed to convince you that it's worth looking at all, we'll move to how to sort of implement and adopt it. Traits. Traits are, I perceive, probably the biggest thing in Scala for people coming from the Java world. Traits are basically partially implemented interfaces. So here's an example. This is a class that you've probably written, once again, hundreds of over the last few months. Okay, it's a pretty simple class. It just takes an SLF4J logger and it does some stuff. And it has two problems. The first problem is this is boilerplate. You don't give a crap about that. You just want to have a class that has logs. You want to get a log instance or something that you can work with, and you don't want to have to write all of that stuff over and over and over again. So if any of you recall that wonderful point about 10 years ago when SLF4J came along and people started migrating either from JavaU to logging or log4j to SLF4J, you just basically had to do a massive search replace on your code base and recompile everything. That's boilerplate. Okay, this is incidental code that you don't want to have, you don't give a crap about. That's the first problem. And you have to write this for every single class with logs, and you probably have 1,000 of them in your production systems. That's a lot of boilerplate. Second, eager evaluation. So, in this example, and this is I know this is a really contrived and very stupid example, but if you have this debug message, you're constructing a string before you produce the log message that is not very likely to actually get logged. Okay, that is why in your production code you probably have thousands upon thousands of instances of code that looks like if log.isDebug enabled, do this. Okay, and that's annoying. You don't want to have to deal with that. Okay, syntactically it's just annoying. It clutters up your code and it's completely incidental. So these are two things that Scala can help us solve. What we want to have, and this is the Scala version of the code. We want to have the same class called class with logs. We wanted to extend something called logging. Okay, we wanted to just say, okay, here's a bit of behavior that deals with logging, give it to me, and I'll use it. And then when we have the same function called normalize name, we just want to be able to call, whatever, the names don't matter, but say log info, log debug. It's pretty much the same code, but we want this to not have the boilerplate and also have lazy evaluation for things like the bug messages. Okay, here is our trait. Okay, this trait is once again like a partially implemented interface. Okay, Java 8 has something very, very, very limited that can somewhat be compared to traits, which is default method, default interface method implementations. Okay, that's for various reasons a lot more limited. So in Scala, I would define a trait called logging, and it has a private value, which is something that you cannot have in a Java interface, even in Java 8. And the second thing I would do is I would define these methods that do exactly as you'd expect. If log.isInfo enabled, log.info message. Now the thing to notice is this little arrow here that looks a little bit like a lambda in Scala. Okay, lambdas in Scala, by the way, have an equal sign instead of a dash, as opposed to Java 8, but largely look the same. So once I mark a parameter as this, it's called a by name parameter. It means that it gets lazily evaluated. What this means is that whenever someone actually calls log debug, okay, they don't pass in the value of this expression. They pass in something that, when invoked, evaluates to the computation that is this expression. Okay, and all of this happens under the hood. You don't have to worry about it. What this means is that if I annotate the message as something that generates a string, a by name parameter, it only ever gets evaluated when the code at runtime reaches this point. Okay, so if this, if log is debug enabled evaluates to false, the message never gets evaluated, and the computation never happens, and the string, the large string, or the dump of the JSON object that you got that did not serialize correctly, or anything of the sort, just doesn't happen. Okay, so it's a nifty trick that can save you a whole lot of code. Yeah, there's a question. Do I have a mic for questions, or? Yeah. Okay, over there.
But you have to allocate object here for function, right?
I'm sorry?
You have to allocate the object for function.
For which function?
That you pass to log info or log debug.
Oh yeah, there is an allocation here, but depending on what computation actually happens, typically escape analysis would render it stack only. So there's no, in practice on the fly, there isn't actually any allocation in place. There can be, but here's the thing. For 99-point-something% of the code, you don't really care, right? There's an allocation. It's a new generation, small bit of data that gets thrown away on the next minor GC. You don't really care about that except for highly performance-sensitive code, which is typically very little, And also, when you actually care about performance, then you don't mind digging deep or having, hacks in your code or trading off some verbosity for performance. But it's just for that bit of code. On average, you don't care about that. Whereas serializing your massive, massive JSON object is actually a problem. Okay, so moving on. DSLs. Okay, that's a small showcase. Here are things you can do in Scala. Okay, this is a test class in Scala. And if you've ever seen a talk about BDD, you'd notice that this actually looks a lot more like BDD than a JUnit test class or test fixture. Okay, which is very, very nice. You can have DSLs for various types of things. So here's another example. Okay, if you would want to have a system where within the confines of the Scala language, you can define purchase orders on shares very easily. You can define that as a DSL within your code base in Scala, right? So this is not an external language. This is just using features of Scala to produce a language that's domain specific, but built on top of Scala. So that's a pretty powerful feature of the language. It's pretty advanced, but it's worth looking into. A lot of libraries do this to give you some specialized syntax for whatever it is that they're meant to do. So, in conclusion of this part, right? Contrasting Java 8 with Scala. What about Java 8? I often get asked the question, with Java 8, is Scala still relevant? I would argue that yes. Okay, Java 8 is a huge step forward. It's been in the coming for a long time. Lambdas alone have been, under discussion for 10 years, and it took forever for them to get into Java. And now that they're finally here, it's a huge step up for Java programmers, but it just doesn't go far enough. The language is still very severely limited. What it does do is, with lambdas, with optionals, with the streams API, it's basically sort of caught up to some of what Scala's been doing for the last 10 years, but it just doesn't go as far. So closures and lambdas are a lot more limited in Java. You don't get proper function types for very good reasons in Java 8, but still, it's still a limitation. Default methods are a lot more limited compared to traits, and that's just scratching the surface, because throughout this half an hour that I've been talking, I haven't touched on any of this massive list of things that Scala brings to the table that, on average, Java 8 does not. Okay, so these are incredibly powerful features. Each one is interesting in of itself, but we're literally just scratching the surface with what Scala is about. So I hope that I've managed to demonstrate that even with the simplest code that doesn't do much, that doesn't take advantage of many of Scala's advanced features, there are still gains to be had by switching from Java to Scala. So that's the first point. Moving on. Suppose now that you're interested in Scala and you want to migrate. Okay, how do you pitch this? How do you sell this to your teammates and your boss? So at this point, let's take a step back and discuss the ecosystem. So Scala is, as you might have noticed, a statically typed language. More importantly, it resides on the JVM. Okay, so in a sense, it's a drop-in. It's not even a replacement. It's a drop-in addition to Java. You can have Java and Scala in the same code base, in the same class path. Okay, working in conjunction, interoperating. You can, and you often do have that. So in terms of the sort of tools that you use, really, okay, I'm gonna switch the slides a little bit. The tools that you use are the same tools. Okay, you get the same IDEs, whether you're using IntelliJ, which would be my recommendation, but to each their own. You can use NetBeans, you can use Eclipse. Each one of these has a very, very, at this point, mature Scala story. Okay, Scala plugins, the things that you need to effectively work with Scala code. In terms of build tools, pretty much everything supports Scala. The one above, SBT, which you may not have heard of, is actually the native build tool for Scala. It makes it easier to work with Scala. But if you still use Maven, as, by the way, we do at Wix, okay, you just add a Maven plugin, a little bit of configuration, and you're wired to go. Okay, your Scala code compiles along with your Java classes and interoperates just fine. Okay, so it's really easy to get started with Scala as a drop-in addition or replacement in an existing Java code base. Where to learn Scala? So as opposed to a few years ago, nowadays there's actually a lot of resources out there. Okay, there's online training courses and all of the above, Safari, Parlays, Pluralsight, the famous Coursera course on functional programming with Scala. Okay, all of these are available. I couldn't necessarily say whether or not they're particularly good because I haven't actually experienced any of them, but there's a lot nowadays. Okay, and they seem to be getting good reviews. Also, there's the usual stuff. Like the community, the Scala community is actually pretty big, and more importantly, is actually pretty active. So if you have a question about Scala, ask it on Stack Overflow, you're almost assured to get a response. Okay, there are a lot of people who are very active and very, very helpful. Also, there's the usual Facebook groups, GitHub, lots of projects in GitHub. Typically, if it's Scala, then it's open source and to be found on GitHub. Twitter, there's communities everywhere. So it's really, really easy to find stuff and to find people and to find help, depending on what it is you're looking for. In terms of libraries and frameworks, the sort of bread and butter of Java and Scala developers, you actually have, okay, before I actually get to the Scala-specific tools, did I mention that Scala is a JVM language? Did I mention that it interoperates with Java? What this basically means is that you can use everything that you're familiar with. If you use Joda, you can continue using Joda. You can use Spring, you can use Juice, you can use Lucene, you can use pretty much any library, Java library that you're used to. And typically the interop overhead, not in terms of performance, in terms of like the code that you have to write, is actually pretty minimal. Okay, on average, you just take your Java class, instantiate it from Scala, call it, and everything works as you'd expect. There are a few things that you occasionally need to tweak, but it's pretty easy. Okay, and a lot of really, really massive Scala projects started off as really, really massive Java projects that were sort of refactored and rebuilt along the way. Our code base is one example. My previous company, we did the same. We started off with a legacy Java code base and slowly migrated it to Scala. Okay, so you can do that. You don't have to lose any of the tools that you're familiar and comfortable with. You can just keep on using them. That includes the Java class library itself, by the way. But if you're looking for that extra zest, you're looking for libraries that actually give you power beyond what the comparable libraries in Java would give you, then here are a few examples. So for testing, which we'll get back to in a bit, there are two sort of commonplace Scala unit testing libraries that are Spex2 and Scala test. They're very comparable. It's a matter of flavor. It's sort of like JUnit and RelaxNG, depending on RelaxNG, is it? I can't recall. MBUnit, whatever, right? Just pick your two favorite Java unit testing framework, compare them, and it's sort of the same, except that, as we'll show in a bit, they're massively more powerful than the typical testing libraries you're used to. Scala check is a completely different beast. It's a property-based testing language. It's a library that basically lets you define rules and then assert that they match. So, whereas you would typically write, if you had a square root function that returns a double, you'd have a unit test case that says something like, if I give a negative number, it should return a not a number, for instance. That's one rule. You would generate random numbers in massive quantities with Scala check. You would tell it, here are the things that are valid inputs to my function, and it will generate quite a few examples of those and make sure that it passes, but it will also generate negative examples. So it'll also generate like negative numbers and see what the behavior is of your function. So it's sort of an inverted look at unit testing. It's a pretty interesting concept. It's worth looking into. It's not specific to Scala, but I'm not familiar with any similar projects in the Java space. ORMs, which is a very sort of touchy subject for a lot of people. I personally think they're the root of all evil, but if you don't, first off, you can just use Hibernate if you're a masochist. If you're not, you have, in the Scala space, you have two very good, pretty lightweight options. One is called Slick, which is sort of they call it the functional relational mapping. It's a very lightweight ORM-ish thing you can use in Scala that's actually pretty effective. And this one is called Scalaic JDBC, which is a different take on sort of a JDBC abstraction without necessarily all of the concepts of object relational mapping built on top of it. It's interesting. I'm not that familiar with, but it's worth looking into. For web frameworks, you have the Play framework, which is pretty famous. You can actually also use it in Java. You have Vertex and you have Lift. All of these are sort of first-class Scala web frameworks. Or you can use Spring MVC, which is unfortunately what we're still doing at Wix. So lastly, there's middleware, right? So you may have heard of Kafka and Spark. I hope you did at any rate. Both are built in Scala. And this little logo down here is Akka, which is an actor model implementation for Scala. It's pretty buzzing right now. If you're interested in it, go read about it. It's an interesting way to build applications. It's very different from sort of the normal model of work. So all of these things are just, you know, cherry-picked examples of stuff that you get in, yeah. So we still have 5 minutes for extras and questions, right? Okay, cool. So I'll be done momentarily. We'll run through the rest of it. There's a very rich library ecosystem that gives you power beyond what you would use in Java, but you can always fall back on what you're comfortable with, which is a huge boon. Just a couple words on this. Scala does not target just server code. It's sort of the native use case for it, but you can also compile it to JavaScript with Scala.js or to Android. These are very interesting use cases on which I will not spend any more time. Bullet number 3, community. This is relevant to you guys. I did some Googling. I hope I managed to get everything right. But from what I could tell, there is one Scala user group in Ukraine. It's called Scala UA, founded in 2011. I know George Leontiev, who's one of the guys who's sort of an early member. These are the links, and I'll also share the deck. There seems to be meetups every now and then. I don't know how regular it is. I'm not familiar with the local scene, but there apparently is some. Conferences. So as you may have noticed, we're at JEEConf, and there's quite a lot of Scala material, so obviously there's interest. There are no Scala-specific conferences that I'm aware of in Ukraine, but there are some in Europe in general and in the States, and there's quite a bit of Scala content in Java-focused conferences. So the community is big, it's very active, and it's very eager. Last point before we wrap up, velocity. If you actually want to tackle migrating to Scala, you know, it's a new piece of technology and it's scary, right? Whenever you hear of a new language or a new ecosystem, whatever, you start thinking rewrites, and rewrites are scary. And they should be scary because they never work. Okay, so basically introducing a new tech into your tech stack is always about managing risk. And there's 4 ways of doing that with Scala that I would recommend. You should probably employ different ones in different contexts. First is the gateway drug, right? Writing tests in Scala is awesome, and it's a really, really easy way to introduce Scala into your code base with 0 risk, because tests are not production code, right? So that alleviates a lot of risk right there. And you can also introduce them in a separate compilation phase, and it's very sort of dedicated, and you can just plug it in very simply, and it has no effect on your production code base. So it's sort of a very easy way to start using Scala in practice without introducing a lot of risk. I highly recommend it. Second is the Greenfield project. If you have a new project, it's a no-brainer. What's the worst case that can happen? You'll be set back by about a month. That's generally not too high a risk for a new project. So it's always easiest to start off fresh. Third, if you have a massive application, typically it's layered, right? You'd have, for instance, in this case, you'd have some sort of deployment process and a bunch of frameworks that you're built on top of, and then you have components built on top of these frameworks. So you may have a web layer with a bunch of different applications built on top of that web layer in your sort of overall system. So you can just replace a layer specifically with Scala using the same interfaces. That's one possibility. Or you can replace specific components that rely on these interfaces in isolation. So some combination of these techniques is my recommended approach to trying out Scala safely and then possibly adopting it long-term in your organization. Literally last point, which shouldn't take more than 30 seconds, peopleware, by which I mean introducing any interesting change into your organization is a surefire way to get your people interested, excited, and happy. And you want your engineers to be excited and happy because that's when they're at their best. So use a pilot project, which by peopleware's definition is one in which you try some new technique or technology and you do not necessarily expect good results. The other thing that happens out of that is something called the Hawthorne Effect, which asserts that people basically, at least in the short term, increase their productivity when they know they're being observed. So if you tell people, we're watching you, at least for a little bit, they're gonna behave, better. They're not gonna screw up as often. And, I'll pretty much finish with that. We still have, I think, a couple minutes for questions. So if there are any, microphone thingy?
How much it takes for a regular Java developer to become a confident Scala developer?
So I suppose it means, it depends on what you mean by confident. In my experience, what typically happens is that it takes up to a couple of weeks just to sort of figure out where you're at. Just staring at Java, moving from Java to staring at Scala for the first time. It takes you a couple of weeks to start to recognize the syntax without thinking about it too much and starting to really kind of write actual code. In my experience, it takes Java developers on average about 2 months to get to the level of comfort with Scala that they've previously enjoyed with Java. What happens after that is that they run into all of these nifty, cool new features in Scala and start playing around a lot. So it doesn't actually take a long time to get comfortable in Scala, but you need to also allocate time for people to experiment and retrace their steps. So if you're interested in Scala, you should, the ideal process is to give your people 1 or 2 months of just getting used to it time, and then know that you're going to take a limited productivity hit for another couple of months while people try out new stuff, learn what works and what doesn't, and give them sort of the mandate to go back, say, okay, we did that, this was a terrible idea, let's rewrite that small piece of code because we went too far with Scala features that we did not necessarily know how to use or know when to employ. So, we've found that new employees coming from a Java background at Twix typically get very comfortable in a couple of months and really, really sort of kind of expert level, in up to 6 months. Sure. Any other questions? Yeah.
Okay, let's assume that you have sold, quote unquote, sold Scala to a certain developer or a team.
I love your optimism.
And yeah, well, or maybe you have a certain product developed in Scala and you have a new team member. How would you actually motivate them to write more idiomatic code, like immutable stuff, like monads, etc.?
Okay, so right off the bat, monads are not what I would consider idiomatic Scala code. I would consider them to be idiomatic functional programming style code. There is a reason why I haven't said the expression functional programming even once in the last 45 minutes, and that's because it's A, scary, and B, just not necessarily necessary in most cases. So you can learn to write better Java in Scala very, very quickly, and if you want to branch out from there to type theory, to functional programming, to various other sort of more advanced programming styles, you're welcome to them. I would actively discourage employees, unless you're a purely functional programming style shop, I would discourage new employees from venturing there before they're really, really comfortable with the language and before they're sort of at the general level the team is in, and then you can start experimenting. But there is no substitute to mentoring, pairing, code reviews, and the usual stuff that you do whenever you bring a new team member in. Scala is no exception to that rule. Okay, I think we're out of time. Scala included, yeah. Okay, so if you have any questions, catch me in a break, ask me at the panel. Thank you.